Alright, and so in this video we're going to look at how to find the area of a sector of a circle, so a section of a circle that is formed by a central angle. And again, let's start with the area of a circle that you are familiar with from geometry or from middle school when you looked at area of different shapes. So if you recall, the area of a circle can be calculated by pi r squared. Right? Area is always unit squared. So circumference is 2 pi r, area is pi r squared. They both have pi, r, and a 2. And how I remember which one is which is always think of area as unit squared. So the one with the square is area. Area of an entire circle is calculated by pi times the radius squared. And again, r is my radius. And then let's again think about where this pi comes from. Now, if we think about the central angle of an entire circle, because we're working with an entire circle here, the area of an entire circle, so the central angle of an entire circle is really 2 pi radian. But in the formula, we only have 1 pi. And so in the formula, we're only using half of the central angle. Half of the central angle theta. Okay, so the area is going to be a half of the central angle theta, but because we have a full circle, which is 2 pi, half of that is 1 pi times the radius squared. And that's the same for the area of any sector, regardless of whether it's in the entire circle, half the circle, or a small chunk of the circle formed by the central angle. The area is going to be calculated by a half of the central angle theta times the radius squared. And again, remember that theta always has to be in radians. So if it's given to you in degrees, you have to convert it to radian. So let's use this formula to find the area of any sector. And your angle theta in this case is right there. And we're looking for the area of this section. Okay, so if you think about a slice of pizza, the area will be, well, what is the slice of pizza? What's the area of the slice of pizza that you ate? All right. So here we have 2 circles, and the highlighted dark is the area of the sector that we're looking for. So in the first circle, we're looking for the area of this section of the circle, right? The area of that sector. And in the second circle, we're looking for the area of this sector. And the sector in the first circle is formed by an angle of 4 pi over 3 radian, and the circle has a radius of 11 inches. So let's start by writing out the formula. Area of a sector is 1/2 of whatever the central angle is times the radius squared. So the radius is given to us, it's 11, and theta is also given to us in radian. So we're all good to plug it into the formula. Area is 1/2 times 4 pi over 3 radian times 11 squared. If you want to write it as a fraction, that's 11 squared over 1. And so let's simplify. I can do 11 squared is 121, and then I can multiply by 4 and divide by 6 if I want to multiply across first and then reduce, right? Or you could reduce now before multiplying. So if I reduce now, I can do 4 divided by 2 is 2. And so we really have 2 times 11 squared is 121. So that's going to be 242. The area of this sector is 242 pi over 3. Now, because we're talking about area, area is unit squared, so that will be square inches, or inches squared would be the exact answer. All right, and then certainly if you put this into your calculator, including the pi, you can get that, oh, that's roughly 253.4 square inches. But we don't have to round, we can just leave our answer in terms of pi as the exact answer. So the next problem, very similar. The only difference is that my angle, my central angle, which I want to be in radians, is not in radians. So we have to do a little bit of converting, right? So I'm just going to convert on the side here. Want to convert 120 degrees to radians, and we're going to again multiply by our special 1. And I want to cross out degrees, so I'm going to put 180 degrees on the bottom so that it can cancel out. And I'm going to put pi radians on the top. And again, entirely up to you whether you want to write the word radian. Usually when the degree symbol is not there, we assume that it's in radian measure, but sometimes it helps if you just put the unit there too, entirely up to you. So degrees cancel out, and I have 120 divided by 180, so I can reduce that, right? Can divide both by 10, so cancel out the 0, and then 12 over 18. 6 goes into 12 2 times, and 6 goes into 18 3 times. So that reduces to 2 pi over 3 radian. And once I have my angle in radian, we can go ahead and plug into the formula. The area is equal to 1/2 times my central angle, which is 2 pi over 3 radian, times my radius squared, so 19 squared. Okay, and then again, you can reduce first if you want. 2 divided by 2 cancels out. And then in our calculator, we're going to do 19 squared, which gives me 361 pi over 3, which doesn't reduce, so we'll just leave it exact as 361 pi over 3 miles squared. And that's our exact area. And again, if you want a rounded answer, if the question asks you to round, then all you have to do is type this into the calculator and round to whatever decimal place. All right, so for both area of a sector and arc length, it uses the central angle and it uses the radius. The formula is slightly different, but it uses the same information. And you know that the central angle has to be in radian form. So make sure that if the problem gives you the radius, if the problem gives you the central angle as degrees, you have to convert that central angle into radian.